Okay, today we're going to be talking about graphing exponential equations. Now, these are fun to graph. They don't create straight lines or anything like that. What they create are curves. Okay, we're going to have a curved line when we do these. Okay, so when we graph them, you'll notice we don't have any slope or y-intercept to start from. We just have y equals 3 to the x power. So anytime we're graphing the exponential equation, what we're going to do is we are going to create a table. Okay? And then we're just going to pick 3 x values to plug in to see what our corresponding y value is. Now, I always recommend doing the values that are close to the origin here. So between 2 and -2 would be what I would suggest. So we're going to use, for this worksheet, we're going to use the same 3 x values every time. Okay, so you don't have to guess what x values you're going to graph. You're going to graph -2, 0, and 2. And you're going to use these same 3 x values on every single graph on this worksheet. So when you start, you can just write in -2, 0, 2 for every table on that graph. Then you just got to plug in the value to figure out what the y value is. Now, because these are exponential equations, we're going to have negative numbers in our exponent. So the common mistake here is people think, oh, -2 is just the same as, saying 3 squared, but it would be negative, so you're going to get a -9 instead of a +9. No, that is not true. Whenever we use a negative exponent, negative exponents are not negative numbers. Negative exponents are fractions. Okay, they are fractions. Okay, and we can check that on our calculator here. If I do 3 to the -2 power, okay, it shoots me back 0.11111. Okay, and if I wanted to write that as a fraction, 0.1111 is the same as saying 1/9, right? Because what actually happens is this is the old man scenario. Okay, old man scenario, if I have a negative exponent, he has to go downstairs to become positive, and it would be 1/3 squared, which is the same as 1/9. Okay, and if I find the decimal of that, 1/9 is 0.1 repeating. Okay, so I'll just write that as a decimal because that's probably what we're going to get on our calculator. So 0.1 repeating. It's also easier to graph a decimal than try to figure out where a fraction would go. Barely. It's about the same. Okay, then let's plug in 3 to the 0 power. So 3 to the 0 power. Now this is one of our exponential properties. Any number raised to 0 is always going to give me the same answer. I could take 1,000,000,000 and raise it to the 0 power, and I'm going to get the same answer. Any number raised to 0 is always going to be 1. Okay, it doesn't matter what number you raise to 0, it's always just going to be 1. Okay? Then we'll try 3 squared. So 3 squared is going to be 3 times 3, which is 9. Okay? So now what I have here are basically 3 ordered pairs. Okay? -2.1, 0, 1, 2, 9. Okay, so when I graph them, let's come over here to -2. 0.1 is just right there above the line, just barely. So right there, it's hard to see. Let me zoom you in a little bit more. Okay, so it's just right there above the line. Okay, and then 0, 1, I'd go to 0, go up 1. There's that point. And then 2, 9, go to 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a third point. So then when I try to graph all these, if I connect the dots, you'll see it doesn't make a straight line. What it actually does is it makes a curved line. And then as we keep progressing, It just keeps going further and further up like that. But then what happens over here? Does it go past the x-intercept? Well, remember, negative exponents are negative numbers. So as we keep typing in bigger negative numbers, so let's try it. 3 to the negative, 3 to the negative fifth, 0.04. Okay, that's still not less than 0, so it's still above the x-axis. About 3 to the negative 20th. Oh, see, this might make you think it's a negative number, but all it's saying is that this is scientific notation, and you have 10 zeros in front of this 2. So it's still above 0. Okay? And 3 to the negative 5,000. Whoops. Okay, so that's so close to 0 that my calculator called it 0, but it is still not below 0. So what actually happens is your line gets really, really, really close to 0 without ever actually going below it. Okay, it doesn't even matter. So even at like negative 5,000, it's still above 0. We're at 0. You keep going over, and it's never going to go past 0. And we call this a horizontal asymptote. Basically, this is a line that your graphed line will never pass. It'll never get past 0 on the x-axis. It'll go forever with the fraction getting smaller and smaller and smaller as we go without ever actually getting less than 0. Okay? And again, you do the same thing over here when we have the fractions. So let's try doing it with the fractions. You'll see it's pretty much the same, but you'll get kind of a opposite result in a way. So let's try it. So 1 over 4. What I'm going to do, because my calculator doesn't have a fraction button, is I'm just going to convert that to a decimal. So to convert 1 over 4 to a decimal, I go 1 divided by 4, which is 0.25. Okay? So now that I know what the decimal is, I'd go 0.25 and raise it to the negative 2 power. So you'll notice here I got 16. Well, that's interesting. So negative 2 didn't give me a fraction. It gave me a whole number. It gave me 16. Okay, what about 0.25 to the 0 power? And do that. Oh, I get 1. That's right. Any number raised to 0 is always going to be 1. Okay, so 0.25 to the 0 power is 1. And then let's do 0.25 to the 2nd power. Oh, this time it gave me a fraction, or a decimal. 0.625. Okay, so I'll just round that to the nearest hundredth, so 0.06. Okay, so the question is, why do the negative exponents give me a whole number here, and then the whole number give me a decimal or fraction? Well, it's because your base is a fraction. Okay, if your base is a fraction, what it's going to do is it's going to kind of flip your curved line around, and your negative numbers are going to make that into a whole number, and then your whole numbers are going to turn that into it's going to stay a fraction. Okay, so again, when we graph this, we go negative 2, then clear all the way up here to 16. Okay, I think that's 16. No, this is 16. Oop. Yeah, not that one. Okay, and then 0, 1, and then 2 is 0.06, so right there. And so when we connect our dots here, see our horizontal asymptote is now going to the right instead of the left, and our line gets bigger and bigger as we go to the left there. Okay, and that's how you graph a exponential equation.